Welcome to Burris Agronomy U. This is Matt Montgomery, Burris Sales Agronomist. Today, we thought we would begin a series on pre-emerge products for amaranth control. In this session, Session 1, we would like to present a resource that can help growers balance the need for control and the need for resistance management. We want to describe how that resource works and tell you where you can access that resource. If you happen to attend any of our winter agronomic meetings, you know that this phrase has been a popular one. Burris has stressed that the days of a one-pass post-emerge weed management system are over. As much as we would like it to be otherwise, those days are history. And we also said this a time or two. If you don't believe us this year, we're guessing you probably will by next. So why have we been saying this? Why has that phrase become common at Burris? Well, this is why. We're encountering a mess of resistant weed species. Most of those listening know the names. Some parts of the Burris footprint struggle with Roundup-resistant giant ragweed. And we know grower after grower stumbled across mare's tail management issues in 2013. In other words, they found out the hard way that mare's tail simply was not being controlled by glyphosate. In some cases, crews were called out to clean up what synthetic pesticides simply could not. And who can forget the big ones, what some of our friends at Bayer have called driver weeds? I'm talking about the amaranths. I'm talking about water hemp, which nailed many fields in 2013, and Palmer amaranth, that rapid growth yield-shattering relative of water hemp and pigweed. Glyphosate simply struggles to control many of these weeds, and we can only assume that the list of resistant weeds will grow. We know how desperately we need herbicide tools like Roundup, and we want to keep as many tools viable as possible. So our only solution is to throw those weeds a curveball. We have to throw something else out there, something that weeds will have to overcome in addition to glyphosate, for instance. And it seems like pre-emerge products provide one of the simplest pathways toward introducing what we call another mode of action. We're going to take some time to talk about those pre-emerge options today. The subject or target will be the amaranths, water hemp, and Palmer, for example. The resources that we previously alluded to are a series of charts, both for corn and beans. The first chart graphically depicts where various herbicide families and herbicide family combinations reside when it comes to control and resistance risk. The second graph, a copy of the first, provides examples of each herbicide family combination. Let's start by getting ourselves familiar with the design of this chart. The first thing you need to know is that the blue area is the sweet spot on the chart. Products or herbicide MOAs, modes of action, in the blue area provide exceptional control with minimal resistance risk. Remember, the subject is amaranth, and I should say minimal resistance risk as of mid-April when I recorded this session. As you move to the right, potential resistance and confirmed resistance begin to increase. As you move down, the chance for poor control increases and escapes therefore increase as well. Now, the worst place to be is the lower right-hand corner as you face the screen. Here, products fail to provide adequate control and they struggle with exceptional resistance. So let's jump in and show what we mean by giving the example of the soybean pre-emerge chart. Here's chart number 1, the soybean pre-emerge herbicide chart. PPOs and PPO-containing products figure prominently in this graph, making up the upper end of the chart, occupying lots of space in that blue sweet spot. That means the risk of encountering resistance is lower for these products, and it means that these products do a pretty good job on amaranths. You may notice that products containing PPOs and something else are better positioned against resistance development than just using PPOs alone. You'll note that PPO-only products are in the purple part of the chart because only one mode of action is being used. Weeds are being exposed to just one type of chemistry, and resistance risk increases. The combination products in the blue part of the chart throw more than one mode of action, keeping weeds off their resistance development game. In Session 2, we're going to start detailing how modes of action like PPOs work. But for today, we're just trying to get you used to how this chart can be used. Let's start detailing the chart by looking at the rough area of the graph on the lower right-hand side of your screen. That tough spot is occupied by what we call ALS inhibitors. There are some numbers and words there. Let's talk a little about what those numbers and words mean. First off, as you can see in this graph, ALS refers to the mode of action family. A mode of action family represents a group of pesticides, in this case herbicides, that kill a plant using the same general process. You'll also note an alphanumeric code in parentheses in this chart. The H stands for HRAC, H-R-A-C, Herbicide Resistance Action Committee. This organization is dedicated to warding off herbicide resistance, and it has coded each herbicide family with a number to help folks mix it up for weeds. In this case, the HRAC code is HRAC2. HRAC2 represents the ALS family of chemistries. Now, the second accompanying chart then provides examples of ALS products, a reference point, if you will, for those familiar with specific herbicides. In pre-emerge soybean herbicide programs, ALS options may include, but are not limited to, the following: Canopy EX, First Rate, and Python. If you're familiar with these products, we think you now have a reference point for what ALS inhibitors actually are. Now, we also have the same thing for pre-emerge corn herbicides, and the driver weeds in this chart are again the amaranths. So remember, we have the sweet spot, the spot where stuff is controlled well and resistance risk is lower. We have the right-hand side of the chart, which shifts to red, indicating a trend toward resistance. We have the bottom of the chart, which indicates that amaranth control is poor. And remember, the worst part of that chart is the part where control is poor, escapes are more likely, and resistance is also more likely. As we did with corn, we've positioned corn pre-emerge mode of action families in different locations, referencing their ability to control amaranth and referencing how prone they are to resistance development. For instance, we have tagged HPPD inhibitors on the corn pre-chart. We then provide you with examples of herbicides you may have used that fit into those herbicide mode of action families or herbicide combinations. So, for instance, we note that Balance, Callisto, and Laudis are examples of pure HPPD products. Well, we hope that provided you some background on how to use this chart. Next time, we will discuss how these different modes of action work, or at least some of them. In the meantime, should you want to reference this MOA chart, this mode of action chart, we encourage you to glance at the March 18th, 2014 issue of the Burris Buzz. Thanks for watching.